In this video, let's talk about solar indices and what they mean. There's three of them, and solar flux index is the first one. It's often abbreviated SFI. And then an A index is another one, and a K index is the third one that I'll talk about. And in this, I'll give you a 10,000 foot view, and it'll be basically for sideband and CW, not for FT8 or FT4. Those propagation or those modes require much lower solar flux numbers than CW and sideband. So this will be primarily a big view. We're not going to get into big details on propagation, but we'll touch a little bit on that sort of thing. This is a screen capture from the website dx.qsl.net and the propagation. And that group thinks that those numbers are important. There's SFI. In this example, it's 156. The A is 13, and the K is 1. So those are the three things that we'll talk about. You can find those numbers in lots of places. Here's another example. This is on the SDXA homepage. And in this one, this area over here, you can find similar ones to that on several pages. And up at the top there, SFI, solar flux index, 136. The SN is sunspot number. We won't talk too much about that one. And then on the next line, an A of 29 and a K of 0. And one more place you can find them. This example is on the WS7I cluster. And you can either type in sh/wwv/5, or you can go to the WWV tab, which I have there, and then click on the button that says 5 spots. That's over there in the circle. And it gives you the last several values. And in this one, the most recent one is at the bottom. It was in hour 3, 136 for SFI, 29 for A, and 4 for K. So the first one let's talk about is solar flux index. It's a measure of the 10.7 centimeter noise from the sun. It's similar to the sunspot count, but those numbers are different. And since they're similar, I think the solar flux index is a little easier to use. So that's the one I'm going to focus on. And the solar flux index, as well as the sunspot count, varies over the course of the 11-year solar cycle. It also varies over the course of the 27-day solar rotation. Let's look at what the solar flux index has been over the last few years. As I'm sure that you remember, if you're an HF operator, that we've had many months of low solar flux values, so not great conditions for propagation on the HF bands, particularly the upper bands. And we're now in the increasing portion of cycle 25. The cycles get numbered from way back, and this one happens to be 25. So let's take a graphical look at what all that looks like. So here's the solar flux from 2018 up to now. And the solid line that's labeled smoothed is the smooth sunspot number. The smooth one takes a value in a month and the previous 6 months and the next 6 months. So it's always 6 months behind, and averages all those 12 values, and it smooths out all the bouncing around that the solar flux does. So you can see that from 2018 to July or so of 2020, we had low numbers somewhere in the 70s. Then it started to climb. At the end of that solid line, the smooth part, I've got the monthly ones plotted, and there haven't been enough of those to contribute to the smooth ones. And then the red boxes, those are the daily ones, and they vary a lot in that particular graph. And so the smooth ones and the monthlies help take out a lot of that bounciness. Here's a busy graph of what the solar flux means to 20, 15, and 10 meters. And we'll go over each of those by band individually. But this is a handy one to have. It's in the PDF, in the handout that we'll have that goes with this workshop. So let's start with 20 meters. And down here at about any value of solar flux, 20 meters is open to somewhere from around sunrise to sunset. and it's been that way in this graph since 2018. So you don't need much solar flux to have 20 meters open, at least during the daylight hours. When the solar flux jumps to around 135, then 20 meters is open all night to somewhere. There may not be somebody at that somewhere, and so the band may seem like it's closed, but in general, 20 meters is open to somewhere all night long at around a solar flux of 135. And as you can see by all the red ones and the smooth ones as well, we're into that right now. Now let's switch to 15 meters. You need about 95, a solar flux of around 95 for 15 to begin to open up. And what that means is that sometime during the daylight hours, 15 will be open to somewhere. And then so maybe 2 or 3 hours after sunrise to 2 or 3 hours before sunset, 15 will be good. When the solar flux jumps up to around 105, then 15 meters opens after sunrise and it closes before sunset. So maybe an hour on each side of those. That's at 105. Then it really gets good when the solar flux jumps up to 150 or so. And in that one, 15 meters is open around sunrise, maybe a little bit before, and even late into the night, perhaps as late as midnight. 10 meters. When the solar flux gets up to 115, then 10 meters begins to open again, mostly during the daylight hours, a little bit after a couple hours after sunrise, and if it comes in and it goes away, or a few hours before sunset. Then when the solar flux jumps up to 180, then 10 meters is good from sunrise or even a little bit before to early in the evening, a few hours after sunset. And then finally, when things really get good, if the solar flux jumps up to 210, then you get 10 meters open from even before sunrise to after midnight. And that doesn't happen very often, but it's good. The other thing to remember about 10 meters is that these are for propagation off of the F layer. There's several layers in the ionosphere, and this is off the F layers. 10 meters also has propagation off of the E layer, which comes and goes. It's weakly related to the solar flux, not well understood. So you can get openings when solar fluxes are much lower than what I show here, and that's off of the E layer. The other interesting thing about when the solar flux gets up in the high numbers, no exact number, but say from 170 or above, the upper bands 10 and 15 get good, but 20 gets worse. Some of that's because there's not as many people there, but it also doesn't have as good a propagation. So 20 has sort of a band that it's good that I didn't show in these graphs. So that's how you can interpret the solar flux. Now let's talk about the other two indexes, the A index and the K index. Those are measures of solar storms. So the solar storms disturb the Earth's magnetic field. So the magnetic lines get moved around as the particles from the solar storm come, and as they move around, they create disturbance. And those have a greater impact on the low bands, 160, and especially 80 and 40. So more impacts on the lower bands than they do on the higher bands. The A index is open-ended. It begins at 0 and it goes up to large numbers. There's no maximum on that. And the K ranges from 0 to 9. So let's talk about the A index first. It's measured daily at several locations at several times during the day. Conditions are best when A is less than 10. So up to 10, those are good conditions for HF propagation. When A gets in the range of 10 to 30, it's still okay, but not as good as when you'd like it an A in the 10 range. When A gets up to 30 to 50, that's a minor storm, and conditions become much more difficult on the HF bands. And if A goes 50 to 100, that's a major storm. Conditions are very difficult on the HF bands. And there's been a few times when there's been an A of greater than 100, and that's a severe storm. I've never seen one that high, but I've seen them up in an A up in the 70s. In fact, I think within the last month there was one that was nearly 70. The K index. K index, whereas the A index is for a specific location, the K index sort of averages planet-wide conditions. And this one, a K of less than 3 is good. So if you see that, conditions will be reasonably good. More than 5, that's not so good. And then you go up above that, and they're even worse. But one of the interesting things about that is a rising K index indicates worsening HF propagation and improved VHF conditions. And in fact, a K value greater than 3 indicates enhanced auroral activity. So 6 meters might become good, maybe even 10 meters for bouncing off an aurora. And then you can find it published. I haven't observed it, but you can find it published that a K of 5 or more and an A of 30 or more indicates auroral activity is likely. So that'd be the time to get out or to get on 6 meters, point your beam northerly and see what you can find there. So what should you expect when there's a geomagnetic storm? More HF noise. It won't be lightning. That's from thunderstorms. It won't be from electrical stuff in houses because that's there all the time, but just more noise, more background shh type noise. And signals will fade, sometimes rapidly. You might hear them very good, for example, when they're calling CQ, and then when they send or say their call, it just drops out. So fading, that's another indication of geomagnetic storm going on. And signals are weak. What you would normally find or experience somebody with a strong signal in normal times, they'd be much, much weaker. And if you're on a polar path like to Europe, then you'd have rapid fading of the signals coming over the polar paths. So to summarize all this, for HF, higher solar flux values means 15 and 10 are open longer. An A value of 10 is good. That's what you'd like to see, but you can still make contacts at the higher numbers as well. An A value is greater than 30 means it's going to be hard to copy people, but still, again, you can make contacts. A K value of 3 or less is what you would like to see. Greater than 3 means the copy is more difficult, but again, you can make the contacts. And then a little VHF summary thrown in here for good measure. Solar flux values greater than 200 suggest 6 meter is possible, not just aurora, but 6 meter propagation from the F layer. And greater than 30, an A greater than 30 and a K greater than 5 suggest auroral propagation. So that's the 10,000 foot view of what those 3 solar values are, the solar flux index, the A, and the K. But again, those are guidelines, and the best thing is turn the radio on and see what you can find.